Hello everyone, this is Rahul Shrestha here to present you the third part of the chapter Rest in Motion for class 8. So in our last class, we read about speed and velocity and understood how velocity being a vector quantity gives us a better understanding of the position of an object based on the direction it traveled. Now moving forward, the topic of our discussion today is acceleration. If you remember, while discussing about uniform and non-uniform motion, I said to you that most of the objects in our world except for the celestial bodies possesses non-uniform motion, which means that they move with variable or non-constant speed or velocity. Vanessa, all these moving objects keep changing their velocity time to time. Now if the velocity is changing, we might want to know that by how much the velocity changed with the passing time. And this concept of measuring the changing velocity with time is what is known as acceleration. So suppose if there is this car which is currently at rest, which means its velocity is 0 meter per second, starts to move and attains a speed or velocity of say 20 meter per second in 5 seconds. Here, this change in the velocity of the car from 0 meter per second to 20 meter per second tells us that this car is accelerating. And in order to measure this acceleration, we need to see the definition of acceleration first, which says that acceleration is the rate of change of velocity, which can also be written as change in velocity per unit time. And this change in velocity is basically the difference between the initial and the final velocity. Here, the initial velocity is 0 meter per second as the car was initially at rest, and the final velocity is 20 meter per second after time 5 seconds. So the acceleration that we get here is 20 meter per second minus 0 meter per second divided by 5 seconds, which is 4. And now what will be the unit of acceleration here? See, the unit of velocity is meter per second and that of time is second. So the unit of acceleration will be meter per second per second. And if we take this second to the denominator, the unit of acceleration becomes meter per second squared. So in this case, we can say that the car is accelerating at the rate of 4 meter per second squared. Now, this means that with every single passing second of time, the velocity of the car changes or increases by 4 meter per second. So initially, when at rest, the velocity of the car was 0 meter per second. Then it started moving, and after 1 second, the velocity reached to 4 meter per second. Then after 2 seconds, the velocity reached 8 meter per second. And that is how the velocity kept increasing by 4 meter per second every single second until it reached 20 meter per second after the completion of 5 seconds. So here, this increase in the velocity by 4 meter per second every single passing second is what is the acceleration of this car. Now see, here the change in velocity is in the positive direction only, which means that the velocity here is increasing with time. But this change in velocity can also sometimes be negative. Now suppose after the 5th second, the driver notices a puppy on the road, applies the brake and stops the car within 2 seconds. So here, if you take this to be the initial position, the initial velocity of the car becomes 20 meter per second. And the final velocity here will be 0 meter per second as the car comes to a stop. So here you can see that there is a change in velocity, but this change in the velocity is in the negative direction. Or in other words, the velocity is decreasing. If we try to find the acceleration here by applying these values in the formula, you will see that the acceleration will be in negative, which is minus 10 meter per second squared, where this minus sign tells us that the velocity is decreasing with the rate of 10 meter per second every passing second. Now this special case of negative acceleration is also known as retardation or deceleration, and thus you can also say that this car is retarding or decelerating at the rate of 10 meter per second squared. Remember certain important points about acceleration. Acceleration only occurs when there is change in velocity, which means that there will be no acceleration if the body moves with a constant velocity or if the body does not change its velocity with time. Acceleration can be both positive or negative, and the negative acceleration is also termed as retardation or deceleration. So this was all about acceleration for your grade. Now let's move into our next topic, which is equations of motions. So basically, in order to solve various different problems regarding motions in a straight line, we have different equations or formulas known as equations of motion, which is sometimes also known as Shewhart equations, where S refers to distance or displacement, which is measured in meters. U refers to initial velocity measured in meter per second. V is the final velocity measured in again meter per second. A is the acceleration, which is measured in meter per second squared, and T is the time taken measured in seconds. So in order to derive our first equation of motion, we need to go back to our definition of acceleration, which says that it is the rate of change of velocity. This can be written as change in velocity by time. Now this can also be written as final velocity minus initial velocity divided by time, which we can now write as V minus U upon T. So here A or acceleration is V minus U upon T. We have already used this particular formula while finding the acceleration of the car before. Now if we take this T to the other side, because this T is in the denominator on this side, it will become a part of the numerator on the other side. So our equation will now become AT equals to V minus U, which can also be written as V minus U equals to AT. Now if we take this minus U to the other side, this negative sign will change into positive and we'll get our equation to be V equals to AT plus U, which can again be written as V is equal to U plus AT. And this V is equal to U plus AT is our first equation of motion, which we derived from the definition of acceleration. Now in order to find the second equation, let's move to some other definition. If you remember, velocity or average velocity in this case is the displacement per unit time. So we can write average velocity is equal to displacement divided by time. Now average velocity can also be found out by this formula, where this U is again the initial velocity and this V is the final velocity. Let me explain. Just suppose an object moves with an initial velocity of 10 meter per second for certain time from point A to point B, and then it changes its velocity to say 20 meter per second from point B to point C. Now if we need to express the overall velocity of this object from point A to point C, we would have to find its average velocity, which can simply be done by using the formula to find the average, where we add the numbers and divide it by the number of numbers. So here we'll be adding these velocity, which is the initial velocity and the final velocity, and divide it by 2, because we have two velocities here, which is U and V. So if you see now, we have two formulas for finding the average velocity, which means that both of these values are the same, and we can write S divided by T is equal to u plus v divided by 2. Now if we take this t to the other side, our equation now becomes s equal to u plus v upon 2 multiplied by t. And this now is our second equation of motion. Now, using the first and the second equation, we can derive our third equation. What we need to do is just replace this v from the second equation with the value of v from the first equation. Now, if we replace this value of v in our second equation, we'll get this. And if we just add both of this 2, the equation will now become 2u plus at upon 2 multiplied by t. Now multiplying both of this with t will get s equals to 2ut plus at square divided by 2. Now we can write this same equation as this. And if we cancel out both these 2's, our equation will now become something like this, which is s equals to ut plus half at square. And this equation here is our third equation of motion. Now for our fourth and the last equation, we need to get back to our first and second equation, but this time instead of replacing the value of v, we will replace the value of this t here. Now from our first equation, we can get the value of t as v minus u upon a. If we replace this value of t in our second equation, our equation will become something like this. S equals to v plus u upon 2 into v minus u upon a. Now if you paid attention to your algebra classes, you might know that this v plus u multiplied by v minus u can also be written as v square minus u square. And this 2 multiplied by a will be 2a. Now if we take this 2a to the other side, our equation now becomes 2as equals to v square minus u square. So we can now also write this equation like this. And now if we take this u square to the other side, our equation becomes v square equals to u square plus 2as, which is our last equation of motion to be discussed here. Now remember how we derived these equations. The first equation was derived from the definition of acceleration. The second was derived from the definition of average velocity. Then for the third equation, we replaced the value of v in our second equation. And for the fourth one, we replaced the value of t with our second equation. Now all these 4 equations of motion will help us to solve all our numerical problems regarding motion with uniform acceleration, which we will be doing in our forthcoming class. So please do practice these derivations once or twice yourselves. I'm done with today's class. We'll meet again the next time. Till then, take care and be safe. Thank you.